Thank you so much for joining us. We will be here live every other week for 15 minutes to talk about everything NLP with industry insiders. My name is David Talby. I'm the CTO of John Snow Labs. And today I'm very excited to welcome Sanjeev Kumar Karn, who is a senior research scientist at Siemens Healthineers. Sanjeev has many years of experience in using deep learning and NLP techniques in the healthcare industry, and he'll also be speaking at the upcoming Healthcare NLP Summit next week on April 5th and 6th. I'm so glad to have you with us today, Sanjeev. Welcome.
Thank you, David, for inviting. Hello, everyone. Yeah, so my name is Sanjeev Kumar, and I'm a senior research scientist at Siemens Healthineers, Princeton. Yeah, mostly I'm a part of a digital technology and innovation group in Siemens Healthineers, which is a widespread over multiple country. The group, and we work with AI machine learning algorithms, and that's that's pretty much
That's all we look for here.
it.
So you've been working as a research scientist at Siemens for almost 8 years. Can you please give us some examples of how you're using NLP at the company?
Yeah, so David, I was part of for initial few year I was part of a PhD student in Siemens, and then I joined as a research scientist in 2019, and yeah, we work with many different type of NLP techniques. We have information extraction system, and we have for clinical decision support. We do a lot of sentence similarity or semantic similarity and have a dynamic information retrieval system. We do text summarization, as you mentioned. I'll be presenting our innovative work on radiology report summarization, which is a text summarization algorithm in upcoming NLP summit. And yeah, and apart from that, it's not like we just use NLP instead of our method, but also we have certain problem that we address. These problem are very data oriented or very domain oriented problems. So, for example, we have our information extractors system that needs to be adapted to different type of ontologies and types of data, and also type of text. So, for example, text could be very short text like 10 words, very information-rich text like almost every word is connected to other words. So we have a very challenging, I say, problems. So yeah, those kind of NLP algorithms that we develop in here.
Interesting. So you're working now on a project that uses NLP to summarize radiology reports, which is very challenging. Can you tell us a bit more about the solution and where it is being deployed?
Sure. So yeah, so our aim for this project is, as you know, my for larger audience. So what happens when a patient goes to a physician for with certain symptoms or a problem? So first, this physician would request an imaging study for proper diagnosis. So they ask radiologists, they give a reason for examination to radiologists, and then they basically the patient goes through this imaging study. So there are a lot of findings that gets collected, and then the radiologist has to summarize or find out the findings that eventually would lead for a proper diagnosis. So our aim is to provide some recommendation, or we take these findings that were compiled, and we try to summarize into impression, and this would be a recommendation to radiologist,
Mhm.
and he or she might edit it and then pass it back to physician. So we use this for us. One aspect is to explainability. Radiologists need to understand whether the summary that this model emitted um, is linked to certain findings and how they are linked. And this linking could not only be at just sentence level. You also need to understand what are the um, uh, um, pathophysiological conditions that are there in the findings that could be linked to this particular generation. So with that aim, we devised this explainable multi-step radiology summarizing algorithm.
Mhm.
And also the other challenge is data size. We can't get a large number of labeled report with finer annotations. So we wanted to we selected this very lightweight summarizing approach. We use LSTM. We have shown in our experiments that even LSTM, if properly designed, can beat many state-of-art transformer models. Yeah, that's about uh, the the big picture about that algorithm.
Very interesting. So you mentioned explainability and you mentioned human in the loop. Can you tell us a bit about other kind of responsible AI considerations that have been part of the solution? So for example, how do you verify that this works, as well for, say, for men, women, for children and adults, for people with different medical backgrounds, or just when deployed in different countries or hospitals?
Yeah, right. That's a very good question. Yeah, we indeed. So when we train our model, we have a very diverse samples for training. So our this is publicly available data set that this paper that I'm going to present is accepted in ACL. So
Congratulations.
it's
That's a big deal. It's a
yeah,
highly competitive one.
yeah, indeed, and we are happy for that. Yeah, so we have this very diverse training sample. We have both gender balanced data in there. We have pretty much many pathophysiological condition in that data set, and yeah, it is mostly related to patients that are in ICU. So that's one thing. But in general, we have a lot of internal radiology reports. We have Siemens. Um, it's a very large player in imaging studies. So we have many reports, internal reports. So we verify our algorithm on internal reports as well. And if applicable, like as I mentioned, we have an international team. So we um, we
Mhm.
also when available, we also run our model on multilingual data.
Interesting. So on the emerging topic of self-supervised learning, how well positioned is Siemens Healthineers to leverage this technology?
Yeah, yeah, as we mentioned, I mentioned like we have a lot of devices and we collect a lot of images. So we have over
Mhm.
a billion images. We have several thousand reports, and we do a lot of self-supervised. We know, like getting annotation or getting training level is not cheap, especially with clinical takes. So we have to pre-train our model on this large amount of data set that we have, and that is what we do. We do same for images. Do for our takes, and we have a very good infrastructure as well in terms of training. We have a supercomputing center in Edison, New Jersey, and yeah, that has over I think currently we have around 400 petaflops, and we run around uh, over 1,000 AI experiment every day. So
Oh,
and
it's
we
impressive.
invest on self-supervised.
That's impressive scale and good data set to have.
Yeah, indeed.
So given all of that action and experience, what is a trend that you expect to see for NLP in healthcare in the upcoming, say, 5 years?
Indeed, as I mentioned, like and probably everybody who work with AI know, like self supervision would be very strong in many work would be coming out.
Mhm.
Uh, that is what I see, and with self supervision, the other immediate result is like a lot of few cert learning algorithms, and because uh, you have seen like with language model, few cert learning has become very trendy, and you just need few training sample and you get like you even beat state of art that were achieved using large amount of training labor. So self supervision I see would be in train for next couple of years. In terms of clinical setup, I also see like federated learning because sharing data set is challenging. Many hospitals have they want their data set sit in hospital, so federated learning would be also uh, uh, be seen a lot in subsequent years in terms of clinical AI and machine learning.
Are
Um,
are you seeing federated learning efforts already happening in terms of data sharing?
yeah, we at our institution, or organization, we see that quite often. Um, and also multimodal machine learning, that is also very popular at our institution. So we have like reports and imaging for a patient exam. So we try to do multimodal machine learning there. We have time series and collected from various diagnostic equipment. We have a lot of takes coming from there, imaging coming from there. So I see like, you know, self supervision not only for one type of data but multimodal data would be, and I've already started seeing paper, like I recently read paper where they were using images and text and speech all together, not a shallow learning but rather a very learning from the very bottom layers, like from embedding till classification here, and such kind of multimodal machine learning would be very much will be observed in the next few years.
Yeah, and I agree with you. I think yes, the first papers are coming out now, and yes, probably in like 2 to 4 years we'll start seeing this in
Yeah,
production.
and a new type of algorithm as well. More and more contrastive loss, different type of loss. Those kind of things are being observed. Yeah, explainable aspects would also be pretty trendy.
Yep. Yes, that we'll always want explainable aspects in healthcare. Yep. Thank you. So thank you again, Sanjeev, for joining us today. Everyone, be sure to catch his excellent session as well as over 30 other amazing talks from industry leaders focused on NLP best practices, real-world case studies, challenges in applying deep learning and transfer learning in practice, and the latest open source libraries, models, and tools at the Healthcare NLP Summit that's happening next Tuesday and Wednesday. We've dropped the link in the chat here, so you can register today. Thank you very much for joining us today, Sanjeev. I
Thank you.
greatly enjoyed our talk.
Yeah, same here. Thanks.
Thank you.